Good afternoon, everyone. So I am Nilotpal Kapri, and I am working on control system development for transport plasma and at CSIR IMMT, and I am registered at AcSIR as an integrated PhD program. So let's dive into the topic. So I think yesterday DP sir already told some of this, and we are working in the same system. So plasma is a state of matter, fourth state of matter, where electrons and ions stays freely. And we are having this 30 kilowatt DC constant current source, and the anode is this bottom part, the hollow crucible, and this is made of graphite, and cathode is the upper cylinder, which applies the current. And there are why we need to use AI in this field. There are various issues we face in the system, like side arcing. What is side arcing is when electric arc doesn't strike at the bottom of the crucible, but it strikes in the side of the crucible. So it doesn't process through the material. So it is just current is just wasting, and it is going through the crucible and to the anode. And another very biggest issue is this eruption of materials. So it is very much hazardous and dangerous. And in current situation, there are very less control system in India. Like we are depending on the foreign-based control system or control that also too much limited. So we really need automatic control so that we don't need manual monitoring like this. And also we are looking for an current field like critical mineral extraction in from fly ash or red mud like things. So we are thinking of processing this in this thermal plasma to evaporize the material and then extracting the critical minerals. So this is the experiment setup we are having. This is the arc plasma furnace, and this is the cathode, this is anode. And we are acquiring data using this DSpace micro lab box setup. And this is the VFD for controlling the cathode positions, like up and down system is there. And this cathode position really matters in this process. Like it is when it is close, current flows much, and arc generation is more. So this cathode position is very much important. For that purpose, you need AI. And I think Sir has presented yesterday that we have already developed ANN and different CNN based algorithm to monitor it. And so I am going to explain what I am currently doing. So I am doing plasma has a high glow, like you have seen in the previous slide, is a high glow. So we are detecting this light intensity using photodiode. You can see here a photodiode is placed just this is focusing the furnace. So we are capturing the light intensity to process the signal and to know the plasma state and plasma condition. So these are the sensing system I am using, and this is a sample data what I am getting. So you can see as electrode position, this LVDT is giving our electrode position, cathode position, how much above the crucible, and as cathode position is increasing, you can see the voltage is also increasing, and this blue waveform is giving the photodiode light intensity. So it is increasing similarly, but and the relation I have plotted here, LVDT versus photodiode signal. So we are not getting a linear relation, but some peak is there. So reason we have found that here some current fluctuation is there here. For that purpose, it is getting sudden change. So we are correlating this, and we are working on it. This is not yet completed. So we are working on it, and so we can process various CNN-based algorithm, and also we are taking images and processing the arcs and working on it. So if anybody want to collaborate, definitely we can work together and similar. Thank you.
Okay, so this is really a good presentation. Even yesterday also DP Das sir has explained something regarding this.
Yes.
Because I do have a small doubt. When you like place this photo sensor, photo diode
Yes.
to sense that optical energy.
Yes.
So, is not it affecting like the, because since you are talking about plasma thing there,
Yes.
so even if there is like, what kind of like sensitivity is there in that photodiode, so that even if there is a small change in the plasma output,
Actually,
can we,
photodiode is very much sensitive to light, but we are using some kind of filter above it, some kind of lens and dark filter to limit the light and reduce the intensity.
okay,
Because
okay.
plasma glow is so high,
direct,
it saturates the photodiode. You can see in the waveform also, somewhat at the end it saturated the photodiode. So we are using some kind of filter to reduce the intensity and capturing this.
so directly you are not like sensing this plasma.
No.
Rather through some filter you are doing it.
Yeah, through some filter we have to do. So some dark filter means just to reduce the intensity.
Okay, that I understood. Now, so you are capturing all those so after this filtering process, you are capturing all those images,
Signals, yes.
signals, and then you are training your model.
Yeah, then we are training and we are correlating these signals to identify the cathode position where it is, and that means what is the condition of the plasma, means if the reaction is completed. Currently, what we have to see it manually. We have to go to close to the furnace and we have to see it manually whether the reaction is happening or not, where cathode position is. We have to see it. So what we are doing, we are predicting from the computer and we will monitor from the computer only.
So, like, how then you are validating? Like, if you are not going closer to it.
For now, we are going to, but in future we are planning to monitor from the computer only. So we are training this by taking.
How much you can rely on it system?
We are working on it. So
no, currently, like whatever like accuracy you got, how much you can rely on it?
I think this CNN-based algorithm we got about 94% accuracy.
So out of 100 instances, 94 instances, it will say.
It will predict correctly.
Okay.
I have one question. So I have not understood the AI part in this. I mean, where you have used AI.
AI part I am using currently. I am working on it. So, and what is happened
As you
that
said,
already shown yesterday that they had this model to predict the cathode position on algorithm, and another algorithm is CNN based position to predict the argon gas flow, how much gas is flowing through the cathode, and what is the amount of current flowing at the instance.
A couple of minutes back, you were saying that you have implemented CNN and you are getting 94% something accuracy.
That is already got that we are in our setup we worked on it and we got that 94% accuracy.
So how many is applicable to it, sir? How many layers are there in CNN?
Single layer algorithm we have developed.
Only single.
Yes. Single headed layer one algorithm and one is single layer.
What do you mean by single layer algorithm?
Single layer neural network.
Single layer neural network. So there will be any input or output or only a single layer?
Layer is there and input is the images, plasma images, arc images, and output is the current flow and gas. This is predicted.
CNN, you are saying that CNN you are using single layer CNN.
Yes.
Are you sure?
Yes, sir.
How many convolution filters were there? Convolutional filters. You see, in CNN there is a convolution.
Not, sir. In CNN we are not using single layer. In ANN we are using single layer to predict this.
And you are getting 94% accuracy using CNN or what?
Using CNN. That was a different.
No, I am just asking how many layers are there in CNN model, in your CNN model?
It is not my CNN model.
I mean,
not,
in your
model
work.
is working.
So you have not worked on the CNN.
I'm just in second year and I'm just starting on it to apply all this.
Is there any other questions from the participants?
So, what is the temperature of that plasma?
It is about 5,000 degrees centigrade.
So, how they set up their things like it is if it is 10,000 degree, then it can boil anything or all
Yeah.
things.
That's why
And
we have
image cannot be taken from there. So, my question is
camera is placed somewhat. If here is the cathode, here is the anode. So camera is placed like with such distance.
Okay.
So, and taking images, and also we have spectroscopic setup to measure temperature and electron density like things.
How LVDT works on it?
LVDT means so differential voltage transformer.
How it works really?
How it,
Working on LVDT.
I think I have shown it. LVDT is connected to the electrode. So when cathode is going down, this is the part it goes inside to the cylinder. So voltage changes and it gives the signal. And it gives -5 to +5 volt signal that how it is varying. And it gives about 10 centimeter of variance.